They don't want you to know this. The power company is charging you full price for electricity you're not even using. And a man in a holler outside of Harlan, Kentucky figured that out back in 1921, and it cost him everything. His name doesn't matter. What matters is what he built with $4 worth of copper wire and a soup can, and why the utility companies spent the next 100 years making sure nobody talked about it again. Here's the truth your power company counts on you never learning. When electricity travels from the substation to your house, it carries two kinds of power. The first is real power. That's the watts you actually use. The ones that spin your refrigerator, light your bulbs, run your TV. You pay for those. Fair enough. But there's a second kind. Electricians call it reactive power. Think of it like the foam on top of a beer. The utility company pours the whole glass. You only drink the liquid, but you're paying for the whole glass, foam and all. That foam is called reactive power. It builds up in every motor in your house, your fridge, your AC unit, your washing machine. It sloshes back and forth on the line, doing no real work, but the meter doesn't care. It counts it anyway. Utility companies have known about this since the 1890s. Charles Steinmetz, one of the greatest electrical engineers who ever lived, wrote about it in 1921. He proposed a device, a simple coil of wire, that could cancel out that reactive power before the meter ever saw it. He called it power factor correction. Big Electric got quiet real fast after that. Within a decade, Steinmetz was dead. His papers on residential power correction were removed from popular circulation. What replaced them was a utility billing structure that kept the reactive power foam on the meter permanently. Today, commercial factories pay engineers specifically to install power factor correction equipment. It saves them hundreds of thousands of dollars a year. Industrial operations run it as a matter of course. But for your house, the utilities say the equipment is too complex. They say it's not worth it for residential customers. They say the savings are negligible. They are lying to you. The foam on your power bill is real. The suppression of the solution is real. And the mountain men of Appalachia knew exactly how to skim that foam off before they ever paid a dime for it. Now, right here, before I show you the exact build, I need you to do one thing. Hit that subscribe button right now and drop a comment below with the name of your home state. Just your state. That's it. Here's why that matters. The algorithm on this platform buries channels like mine. They don't want this information to spread to independent families. But when you comment your state, it signals to the system that real people in real places care about this. It helps other families in your state find this channel. So hit subscribe. Drop your state below. Then stay with me, because what I'm about to show you is the exact build these old-timers use to keep their meter running slow. What these Appalachian engineers built is a basic power factor correction coil. Don't let the name scare you. This is as simple as wrapping wire around a soup can. Here's what you need. And I mean exactly this. Don't substitute. First, a roll of 14-gauge solid copper wire. Not stranded, solid. You can get this at any hardware store for about $4 a roll. Second, an empty steel soup can, cleaned and dried. Standard size, about 3 inches tall and 3 inches wide. Third, 2 ring terminal connectors. Fourth, a short length of 12-gauge wire for the leads. Fifth, a basic multimeter so you can verify your work. That's it. Total cost under $4 if you already have the terminals. Now here's the build. Strip about ½ an inch off both ends of a 6-foot length of your 14-gauge copper wire. You're going to wrap this wire tightly around the outside of your soup can in a coil. Start at the bottom. Wrap up toward the top in tight, even loops. Each loop should sit flush against the last one. No gaps, no overlaps. When you reach the top, you should have approximately 40 to 50 turns of wire around that can. Leave about 6 inches of wire free at each end. These are your leads, the connection points. Attach your ring terminals to each lead using a crimping tool or pliers. These terminals are how the coil will connect into your circuit. Now here's where old-timers got clever. This coil goes in parallel, not in series, with a large inductive load in your home. The best candidate is your refrigerator. It runs 24 hours a day. It has a compressor motor inside, one of the biggest sources of reactive power in a typical house. To connect it in parallel, you'll run your coil leads to the same outlet or junction point that feeds the refrigerator. One lead to the hot terminal, one lead to neutral. The coil sits alongside the fridge circuit, not in it. What happens next is simple physics. The reactive power that was sloshing back and forth from the fridge motor now has somewhere to go. The coil absorbs it locally. It cancels it before it ever reaches the meter. Instead of the meter measuring the foam and the beer together, it now only sees the beer. Verify your work with the multimeter. Set it to measure AC voltage across the coil leads before connection. You should read your standard line voltage, 120 volts in most American homes. After connection, leave it running for 24 hours. Pull your meter reading before and after. Mountain men who built these reported consistent reductions of 8 to 15% on appliance circuits. With multiple coils on multiple circuits, the cumulative effect compounds. The old-timers didn't stop at one. They built a coil for the fridge, a coil for the washing machine, a coil for the window AC unit, each one addressing the reactive load on that specific circuit, each one running silent. No moving parts, no maintenance, just copper wire and physics. This is not magic. This is not a trick. This is the same engineering principle that industrial facilities spend hundreds of thousands of dollars installing, and it costs $4 worth of copper wire to bring it to your kitchen. The utility companies know this works. The reason they never told you is simple. If every home in America corrected its power factor, the utility companies would see their residential billing drop by an estimated 8 to 15% nationally. On a $1 trillion a year industry, that is not a small number. That is a war they chose to fight by keeping this knowledge in the hollers and out of the textbooks. These mountain men didn't go to engineering school. They went to the creek bank with a coil of wire and figured it out on their own. Because they couldn't afford not to. Now you know what they buried. And you've got the build. In the description below this video, you'll find a link to what I call the 1921 suppressed blueprints. These are the original Steinmetz power correction documents. The ones that disappeared from residential engineering literature after the Rural Electrification Act locked in the utility monopoly. I've tracked them down. I've made them available. Click that link, download those blueprints, study them. And if this video gave you something, if this felt like information that actually matters, hit the like button. Not for me. Hit it to keep this knowledge alive. Every like tells the algorithm that real people want real information. It's the only way channels like this survive. Keep the fire burning.